Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1, Probability, brought to you by Vitan Sir. Last time we started with the exercise 1.3 and completed questions from 1 to 6. You can find that video on the top right corner of your screen. This time we are going to continue with exercise 1.3 and complete the remaining sums numbered 7 to 12. Starting with question number 7. Two aircrafts drop bomb to destroy a bridge. Okay. The probability that a bomb dropped from first aircraft hits the target is 0.9. Okay, pretty good aim. And the probability that a bomb dropped from the second aircraft hits the target is 0.7. Okay, good. The probability of one bomb dropped from both the aircrafts hitting the target is 0.63. Okay, the bridge is destroyed even if one bomb is dropped on it. Find the probability that the bridge is destroyed. That means we don't need both the aircrafts to hit the bridge. At least one of the aircraft bomb hitting the bridge is enough. Now, did you just notice the word I used? At least one. So what we are supposed to calculate is the event of bridge destroying by at least one of the two bombs hitting the bridge. So what we do when at least one word is used? Naturally, we calculate the union of events. Let us first depict the given data into events. Event A is bomb of first aircraft hitting the bridge. That is probability of A is 0.9 already given. Event B is bomb of second aircraft which hits the bridge is probability B, that is 0.7 already given. And both bombs hitting the bridge is naturally A intersection B, that is both bombs of the first and the second aircraft hitting the bridge is A intersection B 0.63. What we need to calculate is at least one of the bombs hitting the bridge, that is A union B, that is A plus B minus A intersection B. That would be 0.9 plus 0.7 minus 0.63. Your answer is 0.97. 0.97 is a pretty good probability, almost a certain event that the bridge is destroyed. Rest in peace, bridge. Eighth question. The probability that a teenage coming to a restaurant for dinner orders a pizza. Okay, dinner of pizza, Italian restaurant. The probability of ordering cold drink is 0.54. Who does not order a cold drink in an Italian restaurant? The probability that teenager orders at least one out of pizza and cold drink is 0.88. You get the point here? The union of events is already given. Find the probability that teenager coming for dinner on a certain day orders only one of the two items from pizza and cold drink. Okay, I should probably read the question again, but before that, the events which given are event A, he orders pizza, that is probability 0.63. Event B, that he orders cold drink, that is probability B 0.54, and at least one basically means the union of events. So union of events is already given. Orders at least one pizza and cold drink, that is P A union B 0.88. Now the main thing starts. The question here is only one of the two items. That means when he orders only one of the two items, that means it can be only pizza or only cold drink. Now, if you remember the events, my probability tutorial 1.3, if not, just check the top right corner of the screen. In that tutorial, I explained the difference events. Difference events mean only one event. If A and B two events are given, the chances of happening of only one event A was the difference event A and B, and the chances of happening of only B event was the difference event B and A. So we have to calculate the probability that either he only orders pizza or he only orders cold drink. Here or depicts the positive sign here. So only pizza is difference event A minus B, and only cold drink is the difference event B minus A. So what we need to do is probability of A minus B plus probability of B minus A. Now the formula was already explained in the same tutorial 1.3, how to calculate those probabilities. So no, maybe not in the same tutorial, but in the later tutorials. Okay. Probability A minus B can be calculated as probability A union B minus probability A. Sorry, not probability A. Probability A union B minus probability B, and probability B minus A can be calculated as probability A union B minus probability A. That means we will write down the values here: 0.88 minus 0.54 plus 0.88 minus 0.63. The answer here will be 0.34 plus 0.25, that is 0.59. So the probability that the teenager coming to a restaurant orders only pizza or only cold drink, that is only one of the two items, is 0.59. But then again, it is not always necessary that we have to follow such a long and complicated formula. Uh, I have another formula in mind which can help you solve this similar kind of a question, but I will depict it using a diagram so you will be very clear what we are actually calculating. This is the universal rectangle in which event circles are there, and what we are calculating here are these events: either only pizza or only cold drink. Now, these highlighted area we are supposed to calculate, and the formula here, or what we are supposed to calculate here, can be depicted as this: that when we find the union values of A and B, that will be highlighting both the circles and then deducting the common part, that is A intersection B. I think you guys must get what I am trying to say here. Just find the union of two events A and B, and then remove the central portion which is common between the both, that is A intersection B. So using this formula we can calculate the same thing using a faster method with lower hard work. So ordering only pizza or only cold drink can be explained as probability A union B minus probability A intersection B. So the addition of two different events becomes union minus intersection. We don't have intersection right now, so how we are going to calculate it? A intersection B will be A plus B minus union, that is 0.63 plus 0.54 minus 0.88 is 0.29. So A intersection B value here is 0.29. So our total of the two difference events will be union minus intersection 0.88 minus 0.29, that is 0.59. As you can see, this is the exact same answer which we got in the last sum, in the last method, the first method. So second method is not actually given in your textbook right now, but I just thought that this will be another of the techniques which you can use to enlargen your vision, that we should not be constructed by the same machinery method, rather we should strive for some other methods or means or techniques of calculation which can make it easier. Probability is not just a concept of a textbook, it's a practical concept used by huge statisticians, and they don't follow those textbook methods. So yes, learn the methods in textbook, but also strive for something better. Moving on to the next question. Question number 9. If A and B are mutually exclusive and exhaustive events in a sample space U, and PA is 2 times PB, then find PA. Now when A and B are mutually exclusive and exhaustive events, what we do is we just add them up and get the one answer. You can find it in my previous tutorial of the law of addition of probability on the top right corner of your screen. So probability A union B will be A plus B, that is 1, because both are mutually exclusive, so no intersection, and exhaustive, so the total is universe, that is 1. Now how are we going to apply that concept here? we are supposed to calculate PA is 2 times PB. So I am going to replace PA in the equation with 2 times PB. So my new equation will be 2PB plus PB is 1. Okay, so I replaced PA in my equation with 2 times PB because that is what given in the question. So 2PB plus PB is 3 times PB, that is 1. So PB is 1 upon 3. Okay, PB is 1 upon 3. I am going to put that value into my original equation of union. So it becomes A plus B 1, and in the place of B I am going to put 1 upon 3. I will change the side of 1 upon 3, so it will be 1 minus 1 upon 3, and to get the LCM 3 minus 1 upon 3, the PA value will be 2 upon 3. So in my original question, the question was calculating the value of the probability of A. So probability of A will be 2 upon 3, and the extra thing which we got is probability of B, which is 1 upon 3. And when you just mentally make a total of them, you will get 3 upon 3, that is 1. So simply just proved. Moving on, question number 10. Three events A, B and C in a sample space are mutually exclusive and exhaustive. That means now we have to think about three events along a sum. If 4PA is equal to 5PB is equal to 3PC, then find PA union C and PB union C. Okay, so 4PA is 5PB is 3PC. I am going to start with A and B first. So 4PA is 5PB, and if I change the side of 5PB, the 5, and take it the opposite side, it will become 4 upon 5PA, that is 5PB. What I am going to do is I am going to convert all these B and C's into A's. You will know the reason of that in a short while. Next, I am taking A and C with me. So 4PA is 3 times PC. So here 4 upon 3PA will be the PC value. And because the events are mutually exclusive and exhaustive, the total of all three events will be 1. So how can we play it out like this? In the place of PB, I am going to put 4 upon 5 PA, and in the place of PC, I am going to put 4 upon 3 PA, and my total will look something like this. Next step is to calculate the LCM, and the divisions are 5 and 3, so naturally my LCM will be 15. So first PA will be multiplied with 15, the 4 upon 5 PA will be multiplied with 3, and 4 upon 3 PA will be multiplied with 5. So I will get 15 plus 12 plus 20 divided by 15, PA is equal to 1. I am going to add the numerators, and the denominator 15 will go to opposite side. It will be 47 PA is equal to 15. When I change the side of 47 as usually, I will get PA is equal to 15 upon 47. So I have got the probability of A, that is 15 upon 47. This probability I am going to put in the equation of PB and PC and get their values as well, because for the calculation of A union C and B union C I will need those values. So PB is 4 upon 5 PA, that is 4 upon 5 into 15 upon 47, and simplified value is 12 upon 47. In the place of PA, I have just put 15 upon 47. Similarly, C will be 4 upon 3 PA, that is 4 upon 3 into 15 upon 47, that is 20 upon 47. So A is 15 upon 47, B is 12 upon 47, C is 20 upon 47. Next, I have to calculate A union C. Now, because they are mutually exclusive, unions basically means additions. So A union C is A plus C, that is 15 upon 47 and 20 upon 47, answering into 35 upon 47. Similarly, B union C is just an addition of B and C, that is 12 upon 47 and 20 upon 47. That would be 32 upon 47. So your answers of the initial question, probability A union C is 35 upon 47, and question B union C is 32 upon 47. Just recap this video if you have any doubts, or it's just a suggestion. Just recap this video once or twice so you will get the concept which I have used in this question. Question number 11. Find A union B union C using the following information about three events A, B and C in a sample space. Okay, the event values are directly given, so easy. PA is 0.65, B is 0.45, C is 25, A union intersection B is 0.25, A intersection C is 0.15, B intersection C is 0.2 and A intersection B intersection C is 0.05. What I can do with them is just calculate probability A union B union C with its initial formula, that is PA plus PB plus PC minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. This you can find in my video of law of addition. Just put the values in the equation which already are given ditto in the question above and add and subtract and you got your answer 0.80. Maybe one of the easiest sums of this exercise or maybe the whole chapter, I hope. Moving on to the last question of this exercise and maybe this tutorial also. Question number 12. Let's hope this is as easy as the previous one. Three events A, B and C in a sample space are mutually exclusive. Why do I think it is not that easy? Mutually exclusive and exhaustive. If P C dash is equal to 0.8, 3PB is equal to 2PA dash, then find PA and PB. Why do they like to make it so complicated? Let's do it one by one, one step at a time, because going through one step at a time makes us reach the aim easier. Maybe we may be slower, but we are sure to reach the aim that way. Now PC dash is 0.8. So dash is a complementary event, which means 1 minus the complementary event will get us the original event. So PC is 1 minus PC dash, that is 1 minus 0.8, that is 0.2. We need this. Now these events are mutually exclusive and exhaustive, so naturally A plus B plus C is 1. Of course, remember this kind of things, you have to use them when we are doing the exercise of the same concept. I am going to replace PC with 0.2, and so what I will get is 1 minus 0.2, that is 0.8. Now 3PB is equal to 2PA dash is there, so PB, what I am going to do with my current equation A plus B is equal to 0.8 is I am going to change the side of PA and I will get PB is equal to 0.8 minus PA. This is my equation number 1, so remember this equation properly. Okay, next we will start with the second given equation in the question, that is 3PB is equal to 2PA dash. Now again PA dash is 1 minus PA because those are the complementary events, and in the next step I am going to change the side of the 3 to the opposite, that will be 2 upon 3 1 minus PA. So these two yellow equations you can see, in the first one it is PB is equal to 0.8 minus PA, in the second yellow one PB is equal to 2 upon 3 brackets 1 minus PA. That means PB has two values, and that means both these values must be equal because their left hand side values are equal. So I am going to take the liberty of writing them down like this: 0.8 minus PA is equal to 2 upon 3 1 minus PA. Hope you guys got it. Now in the right hand side I have 2 upon 3, so that denominator 3 I am going to change it to the numerator on the opposite side. It will be 3 times 0.8 minus PA is equal to 2 times 1 minus PA. Just open both the brackets, 0.8 3s are 2.4, that is minus 3 PA is equal to 2 minus 2 PA. I am going to change the sides here. 3PA, which is negative, will be changed to the opposite side to become positive. 2, which is on the right side as positive, will be changed on the left side to become negative. So 2.4 minus 2 is 3PA minus 2PA. Now 2.4 minus 2 is 0.4, of course, and 3PA minus 2PA is PA. So my answer here is PA is equal to 0.4. I hope you guys got this properly. This is a long equation, but we are just halfway there, but we don't need a lot of time now. PA is 0.4, and I'm going to put that value in either of the PB equations. The simpler one is the first one, that is 0.8 minus PA. So in the place of PA, I'm going to write 0.4, and my answer here will be PB is also 0.4. So the question is answered. The values of probability of A is 0.4 and probability of B is also 0.4. So with this, I end my exercise 1.3 with the concept of law of addition. Next time I am planning on starting with the law of multiplication along with conditional probabilities. That is one of the most important topics of this chapter. Actually, all the topics of this chapter are most important, but wait for them. Okay guys, and if any doubts, just rewind these videos or contact me personally. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.